Hi, everybody. This is Mr. Folly, and welcome to our lecture about lab gases. So, here we go. We are going to talk about collecting a gas over water. So, what's going to happen is it's going to be a stoichiometry lab, probably. So, what's going to happen is I'm going to add zinc plus HCl. And I could give you grams of that you can turn into moles, and I could give you milliliters and molarity that you can turn into moles. Okay. And then what's going to happen is if I have zinc plus HCl, I'm going to get ZnCl2 plus H2. And guess what? H2 is a gas. Yeah. And it's going to go bubble, 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 bubble. Okay. So the reaction going to happen in a test tube, or it's going to happen in a graduated cylinder. They call it a measuring cylinder here. And it starts out being super full, and it's going to push down, and you can figure out the volume of the little doodad there. Okay, so the graduated cylinder starts full of water. Gas pushes the water out, and we're going to find the moles of gas using PV equals nRT. Now, here's the one. You must equalize the water levels. So see how this is my measuring tube, and this is water? These need to be exactly the same. So there will very likely be a question where the water level will be here, and this one will be here. Clean this up a bit. Oops, I didn't do so well there. Okay, so if this happens, what that means is the pressure in here is lower, put a P, than outside. So what that means is this pressure of the air is pushing down so hard it's moving the water level up. Okay. So conversely, which shouldn't be too surprising, in this case, this P is higher. So you need to Goldilocks this thing and make sure that they're exactly the same, because that's how you get the pressure. Okay. You have to wait until the temperature is the same as the room. It's called thermal equilibrium. Okay. R is 0.082. We've been using 0.6. Okay. Errors. If we didn't equalize the water levels. Okay. That's the first error I talked about. And the other one is we forgot to subtract the vapor pressure of water. So what happens is they'll give you in very small print, not really small print, but we won't notice it, the pressure of H2O at 27 degrees Celsius is 0.021 atmospheres. So that means when you do this calculation, you have to subtract that off for water. Okay. So let me just show you kind of big time. The pressure is the pressure of the room. Okay. But it's going to be the room minus the pressure of H2O. The volume comes from the graduated cylinder. Equals N, R, which is what we have, and then T. Okay, temperature of the room. Okay, and we're going to calculate that. So hopefully that makes sense. All right, gas stoich. We're going to use PV equals nRT to get moles, use moles over moles to convert to other moles. And just again, the different moles we can have here. Moles equals molarity times volume, or PV equals nRT, or moles equals mass over molar mass. Okay. And that is it. I just want to, oh, no, it's not. Okay, so vapor pressure. So all gases evaporate some. Weaker intermolecular forces evaporate more. Vapor pressure is the force of an evaporated gas back on the liquid. The effective temperature on vapor pressure of liquid. So notice we increase the temperature, it's going to, I have this written down, this isn't right. If we increase the temperature, you want to get rid of that, evaporation increases. Okay, so increasing temperature increases vapor pressure. And a nifty thing about boiling is the real definition of boiling is when vapor pressure equals atmospheric pressure. Not 1 atmosphere, but the pressure of the room. All right. want to talk about mole fractions. Mole fractions are the easiest thing on earth. The fraction of one substance to the entire mixture in moles. A sample of air has 3 moles of N2, 0.5 moles of O2, 0.05 moles of CO2. What is the mole fraction of O2? So O2 is 0.85 over 3 plus 0.85 plus 0.05. 0.85 divided by quantity, 3 plus, is that really 3? That's huge. Plus 0.85 plus 0.05, close parentheses, 0.217. Notice how the mole fraction is a decimal. Okay. A mole fraction is proportional, the same as pressure. So if I do a mole fraction, I can also do a pressure fraction. So also 0.217. 0.217. Partial pressure. If I want to find the partial pressure of something, I can take the mole fraction of a gas times the total pressure. Right? Speed of molecules at the same temperature. Temperature is average kinetic energy. Kinetic energy equals 1/2 mv squared. More massive would be slower. And then we are done. 6 minutes, 33 seconds of joy. Toodles.